Hi everyone, my name is Peng Wang from OceanBase Global. In the next 15 minutes, I will show you how platform teams can run RAG, semantic search, analytics, all on a single database platform, SQL plus vector, running on Kubernetes. The goal is simple: fewer moving parts, lower latency, and easier governance for both structured and unstructured data, all with multi-tenants and strong consistency. Here is today's journey. First, I will share why AI workloads challenge platform teams. Things like fragmented stacks, high latency, and governance issues. Then, we will move from real-world challenges to one platform solution, looking at how a unified approach can simplify operations. Next, I will introduce OceanBase as the unified database for modern AI apps, showing how SQL and vector workloads run together on Kubernetes. Finally, we will wrap up with some closing thoughts and key takeaways that you can bring back to your teams. According to IDC, over 92% of global data is now in an unstructured format. This exactly of data that drives AI workloads like RAG and semantic search. Executives and IT leaders are also recognizing this shift. 41% say RAG as essential, and over 80% believe that Gen AI models using their own enterprise data will be a key competitive edge. And this isn't just a theory. Cloudera's recent research shows enterprises are moving fast. 2/3 are already using enterprise AI infrastructure platforms, and 60% are embedding agentic AI directly into their core applications. So AI workloads are no longer experimental. They are becoming mainstream enterprise critical workloads. And that creates new challenges for platform and the database team, which we will dive into next. Now, if AI workloads are becoming mainstream, the next question is, what does this mean for our technology stack? The reality is different workloads requires very different capability. For intelligent question and answer chatbots, they need low latency access, semantic search, and context awareness. For log analytics, anomaly detection, it needs high ingestion rate, text search, and metric aggregation. For the core business systems, it's component. It needs strong consistency, SAID, and SQL. And because of this, organizations end up stitching together multiple specialized databases: a transactional database, a data warehouse, a vector database, sometimes even a graph or NoSQL engine. The result, the stack is getting complicated. More systems to operate, more ETL pipelines, higher cost, and more risk when workloads span across them. From my conversation with many platform engineers and from our own experiences, this is what most teams wish: one platform for all data workloads, and strong consistency and high availability. Seamless integration with AI pipelines, elastic scaling on Kubernetes, and unified access, and multi-tenants with resource isolation. But here is the reality they face every day, just like fragmented data system. Trade-off between performance and consistency. Complex data movement between services. Difficult scaling across stateful workloads. Inconsistent query models and APIs. Tenant interference and noisy neighbors. Let me make this more concrete with a user case that many enterprises are building today. AI-powered knowledge retrieval for internal teams. This is a conventional architecture. You will notice it looks quite complicated. There is a transactional database for metadata and a vector to store and a vector store for embedding, maybe an Elasticsearch cluster for full text search, and all of this needs to be synchronized with ETL jobs. Now, what does this mean in practice? You'll end up maintaining multiple databases. Synchronization introduces latency and inconsistency. Each additional component adds to the cost and operational risk. And if one part goes down, the whole pipeline can break. This is exactly the kind of fragmented stack we described earlier. Hard to operate, costly to scale, and fragile in production. Now, here is how the team approaches the problem. Instead of stitching together multiple specialized systems, they build on OceanBase as a unified database platform. This allowed them to run both structured states and vector search in the same engine, deploy elastically on Kubernetes, and removes the heavy integration burden. And the results speak for themselves. Query latency dropped by over 70%. Data that used to take hours to refresh is now available in minutes. And the amount of integration code to maintain has been reduced by over 40%. So, by moving to a unified data platform, engineers gained both simplicity and performance, something that was very hard to achieve in a conventional multi-database setup. Let's look at a typical conventional architecture for AI-powered knowledge retrieval. When a user issues a query, the system needs to interact with multiple backend systems. First, it queries MySQL for structured data. Then, it queries the vector database for embeddings. Sometimes Redis is involved for caching. In total, a single request incurs at least 4 network round trips, and the end-to-end latency exceeds 170 milliseconds. On top of that, the platform must maintain data consistency across all their systems, which adds additional complexity and overhead. This is exactly where conventional architectures struggle. Multiple systems, high latency, and complex integration. In the next slide, we will see how we use OceanBase simplifies their stack and reduce latency. With OceanBase, a user query no longer needs to touch multiple backend systems. Instead, the query is handled within a single platform, combining both structured and unstructured data. As a result, the entire request only involves one query, not multiple round trips. End-to-end latency drops to just 50 milliseconds. Data consistency is strongly maintained across the system at all times. This illustrates how consolidating your data and search capability into a single SQL-compatible platform can dramatically reduce latency and simplify operations. Here is a practical example of what we mean by hybrid queries. Imagine a user asking recommended distance within 500 meters, average consumption below $5, rating about 4.5. No queues for the coffee shop. Now, this request involves multiple data types: GIS data for location and distance, relational data for price and rating, vector search for thematic relevance. In most systems, you would need to stitch together different engines to handle this. This means multiple queries, complex integration, and added latency. But with OceanBase, this entire request can be answered with just one SQL statement. That's the power of having structured, spatial, and vector data all unified in a single database. It makes life much simpler for developers and enables faster, smarter application for users. Let me quickly walk you through the OceanBase architecture. First, data is distributed across multiple availability zones, which means we can scale horizontally as workloads grow. On Kubernetes, OceanBase is fully supports operator-based management and allows elastic scaling for both compute and storage. This makes it very cloud native and easy to operate at scale. Second, let's talk about availability and consistency. OceanBase is built on the Paxos consensus algorithm with a triple replica mechanism across availability zones. So even a node or zone fails, we also have automatic, and the system always guarantees strong consistency. In short, the architecture is designed for elasticity, resilience, and trustworthiness, which are critical for AI workloads in production. Another important reason for choosing OceanBase is multi-tenant compatibility. This means that different workloads can run on the same OceanBase clusters while being isolated into separated tenants. Each tenant has its own dedicated resources, so there is no interference across workloads. With this, you truly get one platform for all data workloads. The same engine supports OLTP transactions, log analysis, semantics retrieval, and even AI applications without needing multiple databases. And with the unified access layer, developers can use a single SQL engine to query both structured data and unstructured data, including full text search and vector search. This makes the developer experience much simpler, and it helps platform teams consolidate their database stack. As we wrap up, I'd like to leave you with a few cases. First, one platform, all workloads, built for the next decade. With OceanBase, you can significantly reduce the number of systems in your stack and cut down the integration complexity that platform engineers often struggle with. Second, the same platforms supports both structured and unstructured data. That means OLTP, analytics, full text search, and even vector search for AI workloads all in one place. Third, OceanBase offers elastic scaling and runs natively on Kubernetes, so it fits naturally into modern cloud-native environments. And finally, with fewer systems to integrate and maintain, platform engineers can focus more on delivering value to the business instead of spending time stitching systems together. That's the vision we are driving with OceanBase, a single unified database platform for the next generation of applications. One platform, all workloads, less complexity, more innovation. That's the OceanBase promise. Thank you. Thank you for your time.